the U.S. Navy's Virginia Block V submarine. You might have seen reports like one from the Visgrad Post that China actually called it a merciless hunter.
The United States Navy has unveiled the Virginia-class Block V, the stealthiest and most lethal attack submarine ever built. While China races to expand its naval fleet, this vessel represents a technological leap they cannot match. Virtually invisible to detection, capable of striking anywhere without warning, and equipped with systems so advanced they redefine undersea dominance. But its existence raises deeper questions about the future of naval warfare and whether human crews will even be necessary. The arrival of the Ghost Machine, Block V. The Virginia-class Block V represents a fundamental shift in the balance of undersea power, something that shouldn't exist according to the laws of detection that have governed naval warfare for generations. It makes no sound. It leaves no wake. Launched in 2024, after years of classified development, the Block V is the first fully redesigned attack submarine the United States Navy has produced in over 20 years. Unlike the incremental upgrades that defined earlier Virginia variants, this vessel was built from the beginning to be something different, something unprecedented. It's larger than its predecessors, heavier, packed with technology that even veteran submarine commanders struggle to fully comprehend. The specifications alone tell part of the story. At over 7,800 tons submerged displacement, it dwarfs the original Virginia design. But numbers on paper can't capture what this machine actually represents. At the heart of the Block V sits the S-9G nuclear reactor, a power plant so efficient and so advanced that it will run for more than 30 years without ever needing to refuel. This isn't just an engineering achievement, it's a strategic revolution. A submarine that never needs to surface for fuel is a submarine that can remain hidden indefinitely, constrained only by the limits of human endurance and food supplies. The reactor drives the vessel through water, using pump jet propulsion, a system that eliminates the traditional propeller entirely. Where older submarines pushed themselves forward with rotating blades that chopped through water and created distinctive acoustic signatures, the Block V uses an enclosed jet system that produces almost no detectable sound, but the real magic happens on the hull itself. Every inch of the submarine's exterior is covered with specialized acoustic tiles, advanced materials that don't just deflect sonar, they absorb it. Active sonar pulses that strike the Block V don't bounce back cleanly. They scatter, attenuate, and disappear into the tile matrix, making the submarine appear far smaller than it actually is, or sometimes making it vanish entirely from enemy screens. Inside, every piece of machinery that could produce vibration is mounted on isolated platforms, suspended on advanced dampening systems that prevent sound from traveling through the hull structure. Pumps run quietly. Motors hum at frequencies designed to blend with ocean background noise. Even the crew is trained to move differently, to speak softly, to understand that noise discipline isn't just protocol, it's survival. The operational depth of the Block V remains classified, but experts believe it regularly operates below 500 feet, in the layer of the ocean, where temperature gradients bend sound waves and create natural acoustic shadows. At this depth, with all systems optimized for silence, the submarine's acoustic signature approaches the theoretical minimum, the sound of the ocean itself. It becomes indistinguishable from the background, a ghost that exists in the space between detection and imagination. This level of stealth wasn't achieved overnight. It required decades of research, billions in development costs, and a complete rethinking of submarine design philosophy. But the Block V's true revolution wasn't just about being quiet. Hidden within its extended, the hull was a weapons bay, unlike anything the Navy had ever put to sea. A modular system that would transform the submarine from hunter into something far more dangerous. The Virginia Payload Module, VPM, transformation. The Virginia Payload Module represents the most significant structural modification ever made to an American attack submarine. It wasn't added as an afterthought or a field upgrade. It was designed from the beginning to transform the fundamental purpose of the vessel, to change what a submarine could do, what it could carry, and how it could fight. The VPM contains 4 large vertical launch tubes, each one a silo built into the submarine's body. These aren't the standard torpedo tubes that have defined submarine warfare since World War I. These are strategic weapons platforms, each tube capable of holding 7 Tomahawk cruise missiles in a rotary launcher configuration. Do the math. 4 tubes, 7 missiles each, 28 additional Tomahawks added to the submarine's arsenal. Combined with the 12 missiles already carried in the bow section, a single Block 5 submarine now deploys with 40 Tomahawk missiles, triple the strike capacity of earlier Virginia variants. This isn't just an increase in firepower, it's a fundamental change in naval doctrine. The Block 5 can now conduct sustained land attack operations that previously would have required an entire strike group. It can eliminate coastal defenses, take out command centers, destroy infrastructure, and suppress air defenses, all while remaining completely undetected hundreds of miles offshore. But the VPM's designers built in something even more significant than raw missile capacity. The launch tubes are modular. They can be reconfigured between missions to carry different payloads, depending on operational requirements. Instead of Tomahawks, the tubes can deploy unmanned underwater vehicles, autonomous drones that can scout ahead, map enemy positions, tap undersea cables, or plant surveillance devices on hostile infrastructure. They can carry specialized electronic warfare packages, decoys that mimic the submarine's acoustic signature and draw enemy hunters away from the real vessel. In theory, they could even be configured to deploy smaller, shorter-range hypersonic weapons, though such capabilities remain firmly in the classified realm. This flexibility represents the first truly modular weapons bay in attack submarine history. Previous submarines were built with fixed armaments. What you loaded at port was what you carried for the entire deployment. The Block 5 can adapt. It can shift from a strategic strike platform to an intelligence-gathering vessel to a submarine hunter, all without returning to base. The engineering required to make this work was staggering. Adding 70 feet of hull meant recalculating every structural stress point, rebalancing the submarine's weight distribution, and ensuring that the extended body didn't compromise the vessel's legendary stealth. Every weld had to be perfect. Every seal had to hold at crushing depth. Engineering, the impossible. Birth of the Virginia program. The year was 1991, and the United States Navy had a problem. The Seawolf submarine, the most advanced attack submarine ever conceived, was bleeding the defense budget dry. Each vessel cost nearly $3 billion, a price tag that made sense when the Soviet Union fielded hundreds of submarines, and the Cold War demanded technological supremacy at any cost. But the Soviet Union no longer existed. The Berlin Wall had fallen. The enemy that justified the Seawolf's extraordinary expense had dissolved into 15 separate nations, most of them struggling just to keep their militaries fed and operational. Congress looked at the numbers and made a blunt calculation. The Navy could have 3 Seawolf submarines and watch its submarine fleet age into obsolescence. Or it could design something new, something cheaper, smarter, and built for a world that no longer revolved around a single adversary. The mandate was clear. Design a submarine that cost half as much as the Seawolf, but could still dominate any threat on the horizon. Design it to be adaptable, modular, capable of evolving as missions changed. And design it fast, because America's existing attack submarines were approaching the end of their service lives. The Navy turned to 2 shipyards that had been building submarines since before World War II, Electric Boat in Connecticut and Newport News Shipbuilding in Virginia. What happened next was unprecedented. Instead of competing against each other for a single contract, the 2 yards agreed to collaborate, to share technology, and divide construction in a partnership that had never been attempted on this scale. Electric Boat would design the bow and stern sections. Newport News would build the midsection. Both yards would produce complete submarines simultaneously, doubling the production rate and spreading the industrial base across 2 coasts. But the real revolution happened before a single piece of steel was cut. The Virginia class became the first major warship in American history, designed entirely without paper blueprints. Every component, every system, every structural element was modeled in 3-dimensional digital space. Engineers could simulate how the hull would respond to pressure at depth, how water would flow over the acoustic tiles, how systems would interact in ways that flat drawings could never reveal. They could catch design flaws before they became construction problems, test modifications virtually before committing to expensive physical changes. The innovations came fast. The traditional periscope, a long tube extending from the control room to the top of the sail, was eliminated entirely, replaced by photonic masts, telescoping arrays of high-resolution cameras and sensors that fed digital images directly to control screens. This freed up the control room layout, eliminated a structural weak point in the hull, and allowed the submarine to gather intelligence without exposing any metal above the surface. Fiber optic cables replaced copper wiring throughout the vessel, reducing weight and eliminating electromagnetic interference. Advanced acoustic isolation systems suspended machinery on dampening platforms that prevented vibration from reaching the hull. The entire submarine was designed as an integrated digital architecture, every system networked and monitored in real time. The first Virginia-class submarine, USS Virginia herself, was commissioned in 2004. She was quieter than the Seawolf, despite costing half as much. She was more adaptable, more maintainable, and built for missions that ranged from traditional submarine hunting to covert intelligence gathering in shallow coastal waters. But beneath the success story, beneath the engineering triumph and the budget victory, there were secrets the Navy didn't advertise, costs measured not in dollars, but in human consequences. Secrets, silence, and psychological cost. The Virginia-class Block 5 carries technology so classified that even members of Congress with security clearances don't receive full briefings. The combat systems, the sensor arrays, the software that manages threat detection and weapons deployment, all of it remains locked behind classifications that won't be declassified for decades, if ever. Submarine crews sign non-disclosure agreements that follow them for life. They learn systems they can never discuss, operate equipment they can never describe, and carry knowledge that becomes a permanent burden. Some capabilities can be inferred from oblique references in budget documents and academic papers. There are hints of electromagnetic sonar disruption technology, systems that can interfere with enemy active sonar by generating precise counter frequencies that cancel out the incoming pulses. There are references to deep-water drone communication protocols that allow the submarine to control autonomous vehicles at distances that shouldn't be possible with conventional acoustic signaling. But the most closely guarded secrets aren't technological, they're human. The Navy doesn't publicize what happens to people who spend months sealed inside a steel tube, hundreds of feet underwater, operating machinery that could kill them instantly if anything goes wrong. Maintaining silence protocols that make normal conversation a security risk. A Virginia-class submarine carries a crew of over 100. They live in spaces so cramped that privacy becomes a distant memory. They sleep in berthing compartments stacked 3 high, curtains providing the only separation between bodies. They breathe recycled air, eat food prepared in a galley the size of a small kitchen, and share heads, bathrooms that serve dozens of men at a time. The psychological effect accumulates slowly. Submariners report a sensation they call psychological compression, a feeling that the walls are gradually pressing inward, even though the hull remains structurally sound. Time becomes abstract when you can't see the sun, can't feel weather, can't experience the normal circadian rhythms that regulate human consciousness. The submarine runs on an 18-hour day cycle, 6 hours on watch, 12 hours off, a schedule that sounds reasonable until you realize it means your body never syncs with actual time, never establishes a consistent sleep pattern. You exist in a perpetual state of mild disorientation. Sensory distortion becomes common. Some crew members report hearing sounds that aren't there, phantom pings on sonar, imaginary announcements over the intercom, voices calling their names in empty passageways. Others experience the opposite, a numbing of perception, where real sounds start to feel distant and muffled, as if the ocean itself is insulating them from reality. Anxiety manifests in unexpected ways. A minor equipment malfunction that would barely register on a surface ship becomes a source of intense focus, a potential catastrophe that dominates thoughts for hours. The constant awareness that you're surrounded by thousands of pounds of pressure per square inch, that the only thing between you and instant death is the integrity of the hull, creates a baseline tension that never fully dissipates. Yet these effects are rarely discussed in official channels. The Navy emphasizes the pride, the elite status, the technological superiority. They don't talk about the divorce rates, the sleep disorders, the difficulty many submariners face reintegrating with normal life after deployment. But this psychological burden isn't new. It has roots that stretch back decades, to a time when submarine silence wasn't just doctrine. It was the thin line between peace and nuclear annihilation. The deep roots of fear, Cold War, and lost submarines. There was a war fought beneath the ocean's surface that most people never knew was happening. No shots were fired, no declarations were made. But from the early 1960s until the Soviet Union collapsed, American and Soviet nuclear submarines stalked each other in the deep water, playing a lethal game of cat and mouse that could have triggered global annihilation at any moment. They followed each other for weeks at a time, maintaining positions just outside torpedo range, tracking movements, recording acoustic signatures, testing responses. Each side wanted to know where the other's submarines were, what routes they traveled, what patterns they followed, because in the event of nuclear war, the first priority would be hunting down and destroying the enemy's ballistic missile submarines before they could launch. The pressure on submarine commanders during this period was unlike anything experienced in conventional warfare. They operated under rules of engagement that demanded absolute restraint even when provoked. Soviet submarines would deliberately cross in front of American vessels, testing reaction times, forcing American captains to make split-second decisions about whether to maneuver or hold course. American submarines would park outside Soviet naval bases, recording the acoustic signatures of vessels as they departed, building libraries of sound that would allow them to identify specific submarines by their unique mechanical fingerprints. Both sides knew that a single miscalculation, a collision, an accidental weapons launch, a moment of panic could escalate into full-scale nuclear exchange. The doctrine that emerged from this tension was simple: silence equals survival. A submarine that could not be detected could not be targeted. A submarine that could not be targeted could not be destroyed. And a submarine that could not be destroyed maintained the credibility of nuclear deterrence. The entire strategic calculus of the Cold War depended on submarines remaining hidden on both sides, believing that enough missiles would survive a first strike to deliver catastrophic retaliation. This meant that every design decision, every operational procedure, every training protocol prioritized stealth above all else. Crews learned to move quietly, to speak in whispers during periods of heightened alert, to understand that noise discipline wasn't just important, it was the foundation of national security. But the pursuit of silence came with terrible costs. On April 10, 1963, the USS Thresher was conducting deep-diving tests off the coast of Massachusetts when something went catastrophically wrong. Listeners at a nearby surface ship heard garbled communications, phrases that suggested flooding, references to attempting to blow ballast tanks. Then there was a sound like a ship breaking up, and then nothing. The Thresher and her entire crew of 129 men were gone, crushed at a depth where the pressure exceeded 8,000 pounds per square inch. The Navy launched an investigation that lasted months, but the wreckage was so deep and so scattered that definitive answers never emerged. 5 years later, on May 22, 1968, the USS Scorpion failed to return to port in Norfolk, Virginia. She had been operating near the Azores, conducting routine intelligence patrols. One day, she was communicating normally with Naval Command. The next day, silence. The Scorpion and her crew of 99 men simply vanished. The Navy eventually located the wreckage 10,000 feet down. The hull imploded and broken into sections. The official cause remains classified to this day. These tragedies didn't stop the Cold War submarine program. If anything, they intensified it. The Navy learned from the failures, improved safety protocols, redesigned systems, but the fundamental mission didn't change. Submarines had to be silent. They had to go deep. They had to hunt and be ready to kill, even if it meant operating at the edge of what engineering and human endurance could withstand. That philosophy, forged in Cold War paranoia and tragedy, now drives the Block 5, but with capabilities that would have seemed like science fiction to those early submariners. Block 5, a weapon and an experiment. The Virginia-class Block 5 was designed to do two things simultaneously. Missions that seem contradictory until you understand modern naval warfare. But it's also a strike platform, capable of launching precision attacks against land targets hundreds of miles inland without ever revealing its position. This dual purpose makes it fundamentally different from submarines that came before, vessels that were optimized for one role or the other, but rarely both. As a submarine hunter, the Block 5 carries sophisticated sonar arrays that can detect targets at ranges that remain classified. It processes acoustic data through algorithms that can distinguish between a whale, a merchant ship, and a hostile submarine based on subtle differences in sound frequency and pattern. It can trail an enemy vessel for days, maintaining position in the target's baffles, the acoustic blind spot directly behind the submarine, where its own propulsion noise masks approaching threats. When the time comes to strike, it can launch Mark 48 torpedoes that are themselves intelligent weapons, capable of adjusting their search patterns and reacquiring targets that attempt evasive maneuvers. But the Virginia payload module transforms the Block 5 into something else entirely. Those 28 vertical launch Tomahawk missiles give the submarine strategic reach that extends far beyond the ocean. Each Tomahawk can fly over 1,000 miles, following terrain-hugging flight paths that make them nearly impossible to intercept, striking with precision measured in feet rather than yards. A single Block 5 submarine positioned off a hostile coast can eliminate air defense networks, destroy command bunkers, take out power generation facilities, and crater runways, all within the span of a few hours. It can conduct these strikes without warning, without visible preparation, and without exposing surface vessels to retaliation. The payload tubes are also being configured for the next generation of weapons technology, hypersonic missiles. These weapons travel at speeds exceeding 5 times the speed of sound, covering distances so quickly that traditional defense systems can't react in time to intercept them. Loading hypersonic capability into a submarine that can position itself anywhere in the world's oceans undetected creates a strategic problem that adversaries have no clear answer for. You can't defend against a threat you can't locate. You can't retaliate against an attack when you don't know where it originated. But perhaps the most unsettling capability of the Block 5 is one that doesn't appear in official specifications: AI-assisted combat decision-making. The submarine's combat systems now incorporate machine learning algorithms that can analyze tactical situations and recommend responses faster than human operators can process the information. Early tests suggest these systems improve tactical accuracy by 40%, identifying threat priorities and optimal firing solutions in scenarios where human commanders would still be evaluating options. The AI doesn't make final decisions. Not yet, but it influences them, shapes them, speeds them up in ways that raise uncomfortable questions about the line between assisted decision-making and autonomous warfare. The crew trusts the AI because they've been trained to trust it, because it's proven reliable in simulations and exercises. But there's an underlying tension that no amount of training fully resolves. When the machine sees threats the humans haven't recognized yet, when it recommends actions that seem counterintuitive, when it processes information too quickly for humans to verify. Who's really in command? These questions become even more urgent when you consider what the Navy is building next. Submarines so large and so powerful they exist for one purpose only: to end the world if ordered to do so. The Columbia-class, doomsday below. While the Virginia-class Block 5 represents the cutting edge of attack submarine technology, there's another vessel under construction that dwarfs it in every measurable way. The Columbia-class ballistic missile submarine is the largest underwater vessel the United States has ever built, a nuclear-armed Leviathan designed for a single, apocalyptic purpose. At over 21,000 tons, submerged displacement, and 560 feet in length, It's less a submarine and more an underwater fortress, a mobile nuclear arsenal that exists to guarantee that if America is destroyed, so is whoever destroyed it. The Columbia class carries 16 ballistic missile launch tubes, each one housing a Trident 2D-5 missile, capable of striking targets over 7,000 miles away. Each Trident missile carries multiple independently targetable re-entry vehicles, nuclear warheads, that separate during flight and strike different targets simultaneously. Do the math on a single Columbia-class submarine: 16 missiles, each with multiple warheads, each warhead powerful enough to obliterate a city. One submarine carries more destructive power than all the explosives used in World War II, including the atomic bombs dropped on Hiroshima and Nagasaki, multiplied several times over. These submarines don't hunt enemy vessels. They don't conduct reconnaissance missions or support special operations. They do one thing: they hide. They patrol predetermined areas of ocean, maintaining communication with National Command Authority, waiting for an order that everyone hopes will never come. Their sole purpose is nuclear deterrence, the promise that even if America's land-based missiles are destroyed, even if its bomber fleet is eliminated, even if its cities are burning, there will still be submarines somewhere in the deep ocean with the capability to deliver catastrophic retaliation. The crew of a Columbia-class submarine lives with a psychological burden that's difficult for outsiders to comprehend. They know that if they ever receive launch orders, it means civilization as they understand it has already ended. It means their families, their homes, everything they knew before boarding the submarine is likely gone. And yet, they're trained to execute those orders without hesitation, to turn their keys, to launch their missiles, to participate in the final act of human warfare. This is what the Navy calls doomsday duty, and the screening process for these crews is intense. They undergo psychological evaluations that probe for any indication of hesitation, any moral ambiguity that might interfere with executing launch procedures. The Columbia class is being built to replace the aging Ohio-class ballistic missile submarines, vessels that have patrolled the oceans since the 1980s. The first Columbia submarine is scheduled for commissioning in the early 2030s, with a total of 12 planned over the following decades. Each one costs approximately $8 billion, nearly 3 times the cost of a Virginia-class attack submarine. But the Navy considers this expense non-negotiable. Nuclear deterrence remains the foundation of American strategic doctrine, and ballistic missile submarines are the most survivable leg of the nuclear triad. The reactor that powers these submarines is the same S-9G used in the Block 5, meaning they'll operate for over 30 years without refueling. 30 years of silent patrols, 30 years of waiting. 30 years of crews cycling through deployments, knowing that their entire existence aboard the vessel is predicated on a mission they pray they'll never fulfill. But even the Columbia class, massive and apocalyptic as it is, may represent the last generation of submarines designed primarily for human crews. The Navy's next project exists mostly in classified briefings and leaked budget documents, a submarine program so advanced that it questions whether humans belong underwater at all. The next horizon, SSNX, the Inhuman Era. There's a submarine being designed right now that most people will never see, never hear about, and never understand until it's already operational. The Navy calls it SSNX, a placeholder designation for a classified program that represents the next evolution in undersea warfare. What little information has leaked through budget documents and defense industry conferences suggests something that sounds more like science fiction than military hardware. A submarine that integrates artificial intelligence at such a fundamental level that human crews become optional rather than essential. The SSNX program is exploring technologies that didn't exist even 10 years ago. Adaptive hull materials that can change their acoustic properties in real time, making the submarine appear larger or smaller depending on tactical needs. Quantum navigation systems that determine position without relying on GPS or traditional inertial guidance, making the vessel immune to electronic warfare. Distributed sensor networks where the submarine deploys dozens of autonomous drones that form a sensing web hundreds of miles wide, feeding data back to a central AI that processes threats faster than any human command team could manage. But the most radical element of SSN isn't any single technology. It's the design philosophy. These submarines are being conceived from the beginning to operate with minimal human oversight, not remotely piloted, not supervised from a distance, but genuinely autonomous. The AI wouldn't just assist with tactical decisions, it would make them. It would choose patrol routes, identify targets, assess threats, and potentially engage enemies without waiting for human authorization in scenarios where communication delays could prove fatal. The implications are staggering. A submarine that doesn't need life support systems can dive deeper, stay submerged longer, and take risks that would be unconscionable with human crews aboard. It doesn't suffer from psychological compression, doesn't need sleep, doesn't hesitate during crisis situations. It's the perfect weapon, efficient, tireless, and utterly without conscience. Defense analysts debate whether such systems will ever be fully trusted with lethal authority. The laws of warfare, international treaties, and basic ethical frameworks all assume human decision-makers in the chain of command. But technology has a way of overwhelming policy. Once these systems prove themselves more capable than human operators, once they demonstrate tactical superiority in simulation after simulation, the pressure to deploy them becomes overwhelming. The Navy hasn't officially confirmed when SSN-X will enter service, but budget allocations suggest active development is already underway. Submarines have evolved from silent hunters stalking Cold War adversaries to ghost weapons that can strike anywhere on Earth without warning. Now they stand on the threshold of becoming something else entirely. Independent AI war platforms that operate beyond human control in the ocean's darkest depths. The technology exists. The will to deploy it grows stronger with each strategic challenge. The central question remains unanswered, and perhaps unanswerable. How much control will humans still have when the ocean's deadliest weapon no longer needs them? When the machines we built to protect us become capable of making decisions we can't predict, understand, or override? The submarines are already down there, waiting,